Okay, so we continue with the disk classification. So there also the special type of the disk called the Winchester heads or the Winchester disks. Okay, so Winchester heads. So usually what happens is that when you read from the surface, okay, how you read is this head itself is actually does not touch the surface of the magnetic disk. Okay, it doesn't have the surface. It can just, because it's a magnetic field, you can sense the magnetic field from the very short distance, right? So you can just bring the head close to the surface and this head can sense the magnetic field. But the narrower the head, okay, the closer it must to be to the platter surface to function. Because the density is increasing, right? So in this case, you have the more and more bits on the same size of the surface, right? So for example, if before, for example, with the small hard disks, before you have the 500, let's say the 500 GB. But nowadays, at the same amount of the surface, you can store the 1 terabyte or 2 terabyte. How did we achieve this? By reducing the size, the actual size of each magnetic bit, right? So in this case, the head itself should be able to read the smaller and smaller surface. Okay, so because the surface itself is getting smaller, so our magnetic disks, our head should be able to read from that small, narrow location. Okay, but in this case, you have to bring the head closer and closer to the surface. But if you bring it too close, and then even the very small imperfection like the small dust can actually damage the surface of the hard disk. Even just a tiny speck of the dust can damage the single bit or the 2-3 bits on the surface of the hard disk. So in order to avoid this, there is a special disk classification called the Winchester heads. Okay, so the main difference between the Winchester heads is that first of all, they're sealed inside the vacuum packaging, and then what happens is that when the disk rotates, it will, because of the disk rotation, it will just raise above its original location. Compared to its original location, the disk platter will raise a little bit, okay, and come closer to the reading and writing head. When it's not rotating, it will go back. Okay, again, so when the disk rotates, because of this force generated, the disk will automatically raise and come close to the reading and writing mechanism. But when the disk is again the idle state, it will go back to its original location. Okay, so the air pressure that is generated by rotating the disk will raise the disk above the surface. Okay, these are some of the past year the hard disks. So just to compare them, so nowadays we have the 6 terabytes, 3 terabyte, or 500 GB, 2 terabyte, different types of the disks, right? And they have the different RPM. So RPM is rotations per minute. How many rotations this disk can do in 1 minute. So the higher the number, faster the reading and writing speed. Okay, and this is the latency. So how long it will take before you can actually read from the surface. And this is a transfer rate, right? So 200 megabytes, 100 megabytes, etc. Okay. And these are the number of the sectors, or number of the bytes per sector, number of tracks per cylinder, etc. So these are some of the characteristics of the existing hard drives. Okay, so this is actually the timing of the disk input-output transfer, what you should include here. So when you consider the timing, so of course first the computer have to wait for the device. So if the hard disk is right now busy with other operations, so let's say some other app is requesting something from the hard disk, then some other app have to wait. Okay, wait for the channel. So this is a channel for the data transmission. So as we say that there's interconnection, usually some kind of the bus interconnection, so waiting for the channel. And then the seek, so meaning you have to search for the data on the surface. Where is it? So this is the searching time. Rotational delay, so then you have to rotate the disk and bring it under the reading head, and then actual data transfer. So all of this will take some time. So this is the timing of the input-output transfer. So this is one of the reasons why the hard disk is much more slower compared to the RAM, for example. In case of the RAM, there is no such thing as the rotation delay or the seek time, etc. So you just immediately read from any location at immediately, right? So that's why, for example, the RAM is faster compared to the hard disks. And these are the things that we just explained, right? So these are the things that will affect the disk performance, right? The seek time, rotation delay, the access time, the transfer time, etc.